The old Binny vault across the street and the garage is gone. Everything is fed from this building. So this was the old vault here. We have our new substation downstairs, which picks up all the loads that were originally over the old Binny. It also picks up the 2 feeders for this building here. Basically the same orientation, left and right sides of the board, 2 feeders out to each building. Routing is pretty much the same way, except for manholes 3 and 4, it comes into this building as opposed to going across the street. What else we get in there? There's 2 spare breakers coming for, I guess, the garage and Honeywell.
Yep.
Yeah.
There's 2, the 5 kV transformers are still up in Old Binny.
Yes, they are.
Being fed from this building.
Correct. That's the only thing that's live over there right now.
The 2 spare breakers down there will be actually spares.
Will be spares.
Yeah, the
yes.
ones we're utilizing for old, the 5 kV will be the new
Will be the new,
garage and Honeywell.
yes. Yeah,
One of
all
the
that goes
differences between this board and Old Binny Street is that there's a tiebreaker in this building where up the street both breakers were closed. So there is a tiebreaker and it's normally closed in this sense. So it's basically the same thing you had up there. But you knew that.
I knew that. Yeah, it's still a loop feed, but you do have a tie. But I don't think you guys are going to be involved with operating that. That's Maytep and Star.
Did we finish working that manhole at the top of the driveway?
We'll be 100% in there tomorrow.
Tomorrow.
Tomorrow?
We're doing final inspection tomorrow.
Okay, you had asked earlier on to make sure that that one line back to the vault gets sealed if the manhole fills up with water.
Yes, because it's downhill, hit into the
All right,
wall.
so if you're gonna be here, you'll be able to see that it's.
Yeah,
Okay,
yeah.
I just wanted to check towards the end of this show to make sure
Yep.
that happened.
Yep, we'll be in there tomorrow afternoon.
Okay, good.
All the labeling was done, right?
That's
what
Danny's
the
doing it
inspection-
tomorrow,
yes.
and I'll be here right after lunch to go over it.
Some distribution. Yeah, questions, distribution. I mean, still goes out to the same places, out to the other buildings. All the feeders have been, these are not the, all these feeder numbers have been changed, correct? These aren't what they used to be? The F5A, F5B?
They're still there. We just added the building names to the front
Building
of them.
to
So
them, okay.
like Pavilion, Main, MA is F, and so on and so forth. So when we're in the manholes and we can follow it out, we know.
But are these the way they're marked on the other ends?
No.
Okay,
No, not
that's,
yet.
that's, yeah,
that's
that's
a
what I wanted to
job
at least
that,
let them know that,
Yeah,
yeah, I mean, we're marked feeder numbers
yes,
down here that may not necessarily correspond to the other side, but the labels are there for,
right.
it's for the buildings anyway. From here, we come over, we have our own unit substations down here, just for this building. We have 2 unit substations downstairs with a tiebreaker between them. So again, the whole building could be fed off of one 15 kV breaker over in the main vault. Distribution goes up through the building. There's panels on every floor, normal emergency. 2 normal transfer switches downstairs, which will pick up all the normal power in the building. We have 5 pump taps for both taps, one out of each side of the board. Transfer switch downstairs for the chiller. Basically everything is fed out of there. Distribution goes up. There's distribution panels on every floor. the building is broken up from the 4th floor down, and then the 4th floor up. Everything from 3 down gets fed out of sub-basement. All the smaller panels up from 4 up get fed out of the 4th floor. So there's a distribution panel up on 4 that feeds 4 up, and then distribution panels in the sub-basement that feed from sub-basement up. And that'll feed all your lighting and power panels, normal and emergency. So both risers are pretty much set up the same way, in so much as all the distribution panels are up on 4.
So every panel on each floor has its own feeder breaker down in the distribution panel on 4, from 6 and up. You know, so it's not technically a riser. It's, you know, it's a feeder basically out of a distribution panel. So if you need to shut off a panel up on the 10th floor, there's a breaker down on the 4th floor that will feed it. So you don't have to affect any other panel. It'll just affect that one. Same with the emergency.
Is the building capable of 100% emergency power with the normal transfer switches?
Yes. Yes, there's 2 normal transfer switches, and then there's 1 transfer switch for the chiller.
Okay.
Those are the 3 non-emergency life safety transfer switches, if you would. But yes, the whole building could be put on the generators. We have an MRI on the 2nd floor and the 7th floor. They get fed out of an X-ray panel up on 4. As we walk through the building, I'll point those out to you, but we do have 2 transformers, 1 on 2 and 1 on 7. It's 480 to 440. Those are the only 2 special transformers in the building, and they're exclusively for the MRI. The MRI riser, or distribution panel, is 480 volt though. And it's out of that panel that the individual MRIs are fed with the 440 volt transformers.
How many flywheels in the building?
There are 2 flywheels downstairs. We'll get to them.
X-ray and critical.
Yes, in the emergency electric room, the other 5 transfer switches. I'm sorry, there's 10 total. We have the 2 normals, the chiller, 2 for the fire pump, and in the emergency electric room, excuse me, the other 5. We have equipment power on distribution panel on the 4th floor. That's 1 transfer switch. Equipment power in the penthouse is the 2nd. Life safety, X-ray, and then the critical. The X-ray and the critical risers are backed up by the flywheels. Everything else is just a regular transfer switch, so you'll have the delay on those. The generator power for this building comes out of the main building. So we are tapped onto the 6,000 amp bus over in the main building. Comes directly over here. There's no breakers that will disconnect this building from that switchgear. It's all individual breakers in the distribution board over here.
Coordination study completed?
Coordination study is done. Yeah. What else? Again, the risers over here, almost identical to the normal power. Excuse me. Distribution comes out of the sub-basement up to the 3rd floor, and then from the 4th floor up to 10. What else do we have up there? There is the chillers up in the penthouse. I mentioned before, they're fed off their own transfer switch. So those could be put on the generator, again, at your discretion. Equipment risers, there's a distribution panel on 4. I'm sorry, 1 on the sub-basement, 4, and the penthouse. There's not a whole lot of equipment down on the sub-basement, but there is a panel down there for that. The 4th floor has its own distribution panel, and then the penthouse has its own. Penthouse has a couple of different panels for distribution up there. We have the chillers and the penthouse panel itself.
The life safety, what, ground 8 and 10?
Yes, life safety is every third floor, and they'll feed floor above, floor below. There is
Ground 4, 8, 10.
there is no equipment panels on any floor except for sub-basement, 4th floor in the penthouse. There's no equipment circuits or anything up through the building. Equipment riser circuits. There are critical panels on every floor. All right, we got, this is the Maytep N-Star side of the board. This is our Maytep breaker controls. All the breakers are on the front side of the board. The Maytep N-Star controls are all on this side. Again, I don't believe that's anything you guys are really going to deal with too much, but just so you know what's here. And this is our Maytep breaker, our N-Star breaker, and this is the Tiebreaker. The way the system operates now, it runs in loop, same as across the street. The only difference is you have a breaker that you can separate N-Star and Maytep with. There is no automatic function on this board at all. So N-Star and Maytep have their sequencing about bringing the lines back up. Metering's on this side. I don't know if you guys get into it or not. You can pull up the metering for the board, what it's drawing on this side here. 45 amps on the Maytep line right now. That's not right. I don't know how much you want to really get into whatever's over here.
Yes.
They do have the ground truck, yes.
They have their own. It's actually captured in the other side of the board. We'll show you that when we go over there. They have, and then we have a ground truck also.
Yeah, I don't think we need to really go too much more on this side of it.
What's that?
There's not much more they need to know about this side of the board, right?
No.
Other than that, this is basically all Maytep and stock controls.
They control it. Maytep can open and close their feeder breaker from, or N-Star's feeder breaker from Maytep.
From up in Maytep.
Basically, that's it. If you open the tie, it's going to separate both halves of the board. So it's, that's it. You don't want to really mess with this whole side.
Yeah, you don't want to touch this side.
Hands off. Has nothing to do with yeah, we're going to put some chains up from here over to the wall just to kind of keep everybody out of here. It's on a pass through. You lose this, you lose the campus.
This campus.
Lockout's healthy, yeah. Well, they have a cutout switch here. What it does, it cuts out the high-speed differential, the tripping circuits. So you can actually put those to off, and if you trip a lockout, it will tell you, the light will go out, and obviously just tell you that the lockout's tripped. You know, when the blue light is on, it says lockout healthy, and that means it's good to go. You know, there are some protections for us to do that we've been using as we energize, especially when we first came on.
Yeah.
Or, you know, you're re-energizing some transformers. We put the lockouts in off. So basically, if you had some type of trip, it wouldn't trip your feeder breakers. It would trip a relay. The relay is a high-speed differential, so the tolerances are very small. You can bang these doors and trip these out. So there is that function in there to do that to help protect that. So.
Are they going to post their sequence of operation? I know they have that over in the car. If they're taking out either one of the breakers.
Maytep, I'm not sure what their plans are for there. You know, whether Eddie, I'll talk to Eddie about what they have. I don't know if, I know it's posted on the board at car.
And they do use it when they go in.
Right.
You double check and make sure that.
Here it's a little bit different because it's the buses are a little bit different over there. You've got to actually close the ties of their their buses back at the plant in order for them to parallel up, you know, so they close their tiebreaker, so that's really important for cross-current flow. Here it's a little bit, it's a funkier setup, so I don't think they have the same issue because they're off the same end stop. They're tied to the same end stop feed. Yeah. Yeah. See here, it's an end stop feeder and a MATEP feeder. Over at COP, it's two MATEP feeders, but they come from different buses back at the plant. In order to close the tie, they need to close those buses back at the plant in order for the cables to be able to handle cross-flow currents. So that's why those are instructions are there. I'm not sure if they're going to have that here.
Okay, this is the operating side of the board for you guys. Again, we got a MATEP and end stop breakers here. Indication lights on this side, just to tell you that the breakers are closed, tiebreaker. 3 lines are healthy. We get a little bit of metering over here on their breakers also. Outside of these breakers here are all the feeder breakers out to Children's Campus.
The tie always stays closed.
The tie always remains closed. Again, I'm sure that'll be an end-stop MATEP decision whether that tie gets opened or not, and for whatever reason, things like that. But they're the ones that'll operate this. Normal operation of the board is both mains and the tie closed at all times.
You guys notice that 421A, that A is probably going to be coming off of there at some point. It's the same number.
It's the same station as across the street.
They had to name this one as A, and the old one was 421. So this one here will come down once everything is all squared away down there.
Both sides of the board are identical in so much as you have an A and a B feeder. One comes off one side, one comes off the other. These first ones, these are our substations. So this is F1B. Over that side, you're going to have an F1A, which is the other breaker to our substation, unit substations here in the building. We have 2 capacitor banks in here, one on each side of the room up at the end here. Again, they're fed off of both sides of the board. They are online right now. They're both in automatic. They're designed to stage in and out as necessary. So other than maintenance, I don't think there's a whole lot you guys will have to do on those. They've been pretty much set up. We have a future compartment here, which you saw the boxes on the back side of the board. In that box is a whole door that'll be set up similar to this, so you'll have a future breaker and a whole compartment here. This feeder right now will be the ones that they feed the 5 kV transformers across the street, which is still feeding the garage and Honeywell, which I guess through another project that'll all be upgraded. Then these breakers will be the feeds to those. We want to go through operation of all this, so we've already done the training on this. I mean, it's a simple operation. You got a trip and close handle here. The breaker has to be racked in. I'll open them up. The indication lights will tell you where your breaker is. Your breaker is connected, spring charged. When the breakers go in, they will charge on their own. We'll close them. You have meters on here. See, that cap's out. All the meters out. You can scroll through the meters. It'll give you your voltage, your amperage. If you had to come in, do a quick check to see what's going on with the breakers. Some of these are at 0, but I've been told that a couple of the buildings out there are all off of one side of the feeder, so I'll explain why we got nothing on them. From here, everything pipes up out of this board, and it goes out to the 2 junction boxes up on the other side there, and that goes out to manholes 4 down in front of Enders and manhole 3 up on the corner. All the feeders were intercepted there, so nothing goes back across the street anymore. Your MATEP and end-stop feeders come in through the cans up there also. On the back side of the board in the corner over here is the battery system. That's pretty much what runs this board. They're all sealed batteries, so again, there's very little maintenance on them. There's a little control panel on there to give you alarms. That charger and battery system is what operates this board. There are heaters in here, there are lights in here. Those are all marked on the insides of the doors, the locations that they are, where they're fed from. The board for metering is tied into the BMS system. I don't know if that's online yet or not, but they tied that in a week or two ago, right?
Yeah, I think it is.
Okay.
Is that battery tied back to Yanny?
Not at this time.
Had a major power outage. Some of the things you'd want to look for are those white lights that you see on mains F and N stuff. They're going to tell you the faces that are coming in here. Check the breakers, the red lights on their feeder breakers. It will kind of let you assess of what's happening. You know, if it hits the fan here and we lose, say, a mains F feeder or an N-star feeder, if you come down here, that's the first thing you need to look at, those lights, to make sure you've got both utilities coming in. Then the position of your feeder breakers and your tiebreaker to make sure those 3 red lights over there are closed. You know, and then, call Mike or whoever, and, and then if you're talking to him on the phone, you can kind of quick assess, give him a quick update of what's happening. Maybe it's just a feeder breaker, or maybe you've lost a utility feed, but those would be some of the things you would look for if pick up crazy.
Right now it's on amp,
Yes.
amperage. You could scroll through here.
Okay.
You get watts, VARs.
Alright, so we can see that.
Yeah, you can scroll through
So this
your
is the
volts,
feed. Okay.
line to line.
So it's telling you there's 14,100 or
Oh.
somewhat volts on each phase, or coming in, 3-phase.
Okay, thank you.
Yeah.
The Eaton meter is what's going to trip you offline. You don't mess with that. This meter here, you can actually scroll through. It won't do anything. You can see what, like what Dave just did. You can see your amperage, you can see your voltage, you can see your power, whatever you want, wattage.
If some of the fuse is burned out, so if in case happen, that's this kind of stuff.
No,
You take care of it.
Well,
Yeah.
you shouldn't, you don't want to be touching that.
Don't touch
Yeah, these are all the meter
anything.
disconnect switches, but
okay.
yeah, things like that, yeah, you don't want to be. The only thing you should be really going through on it here is maybe scrolling through this and
And I
actually,
would check your amperage on your heater circuits. Each one has an analog heater. If you were coming in here and doing a walkthrough, which I'm sure you guys will be putting on your list, you would check your heater circuits to make sure each cubicle heater is on and running, and basically that would check your battery. Other than that, there's really not much to do.
yeah.
So if the heater is not running, so we have another problem. You get to open up.
It all depends, yeah, it's 120 DC.
So I remember we have 2 fuses behind the panels and for the heater circuit.
Yeah, you have heater disconnects in there, light disconnects in there. You can actually disconnect the DC in each cubicle behind these doors.
That should be done by Paul Mike or somebody, not us to do, is it?
I don't know.
Okay.
I wouldn't. I don't know who's.
What's that?
If there were an issue inside here, something had to be disconnected. I don't know if that winds up into.
That'd be UPG or one of our service companies that would come in. We wouldn't be getting beyond that door.
Well, like Rich said, just an initial overview of the outside, make sure the lights are lit, meters are on, and then from there the problem can be addressed. Okay. Moving on to the electrical. Coming into the substations, we get a 15 kV on this end. Each side comes off of one side of the board over in the vault. These are looped through. I forget which one we have here. I believe it's this switch here. always the last one. The way these feeders come in, they loop through the switches, so one switch is always left open. The Kirk key arrangement on here is going to prevent you from closing all 4 switches anyway. So in order to close this switch, you'd have to open one of these other 3, remove the key, insert it into here, and then you can close this. So there's no way that you can close all 4 switches in. Electrically speaking, you could do it. Everything is phased properly and everything like that, but the interlocks will prevent you from doing that. Each of these switches are just straight switches off the, next to the switches here are transformer switches. These are the fuse switches here. And these feed each substation transformer on each side. These also have Kirk key interlocks with the main breakers. So if you open the main breaker over there, you can insert the key in here and open this also and lock it out. These don't have meters or anything on them, but there are heaters inside each of the sets of switches here. There's no indication to tell you that they are on or not.
Hey, what's this?
This does feed the train. This one here?
Yeah.
This is your heater thermostat. Yes. No, these don't have. That's the only one.
Where is the key?
They're in.
Switches.
Like I said, this switch is open right now. The other 3 are closed. If you wanted to close this switch, you'd have to open one of these other 3. This key right now is captured. You can't get it out. Once you open the switch, then you could remove this key, insert it into the open switch. Once you turn it, now it captures. Once you close the switch, now it'll capture the key.
And these are all keyed the same.
These are all keyed, so any one of these keys will work in any switch. But there'll always be one switch without a key, and that'll be the open switch. The other guy likes to touch everything, huh?
These ones here on this side have the fuses in it, right?
These are the, yes, these are the fusible switches for the transformers. Moving down, we have our transformers. These do have indications on here. There are fans, there's heaters inside. You can come in and turn them on. They do come on automatically. There are thermostats inside here for the heaters. It will give you an alarm if it goes over temperature or anything like that. It can be silenced here. So, other than that, not a whole lot with the transformers. Moving down here, we got our main breakers. Again, these are double interlocked with we have a tiebreaker and with the 2 transformer breakers over here. So you could lock those switches out if you open this main. One of these keys, once you open the main and rack it out, you can remove these keys. The tiebreaker is also interlocked with the 2 mains, so you have to open one of the mains, again, remove one of the keys, insert it into the tiebreaker, and then you can close that. So again, you can't have 2 two mains and the tiebreaker closed at the same time. One of them will have to be open. Do we have the, which one do I have? Inside these cubicles, we have control transformers. Your disconnects in here for your heaters, the control circuits, and everything that feed the board. You open these up, the lights on these breakers will come out, your meters will go off. Primary disconnect on the transformer itself, that's fed right off the bus in here. So if there's no power in the board, none of this will work either. Inside this board here, we're going to put it back. Inside each one of these compartments will be a ratchet and an extension. That's how you rack the breakers in. Any 3/8 ratchet's going to work, ratchet and extension. But there is one in each of the cubicles here. This is a spare breaker, that's why it's racked out. But again, if you could be racked in, it'll go to its positions, your test position, and if you notice on the other ones, the red light's lit on connect. As soon as that little window is lit, the breaker is racked all the way in. The lever on the front will charge the breaker. You push the green button and it'll close it. They're basically TVSS on both boards, surge suppression. So you get the 4 lights lit. If the lights go off, they turn red. That means you've either got a spike or an issue with the unit.
Does that shut you down at all, or is it just tells you that it took a hit?
It's just going to tell you that it took a hit. Yeah, it will not trip any breakers.
I'm looking for 116, and that's the one.
Oh, 1600? Yeah.
Yeah, they're on the 4
1600, was it a 4 and an 8? I believe.
I saw all 8s, it should have been a 4, right?
It is. I'm just a little confused with the 13/8 switches.
Yes.
You got 2 feeders coming in, but on this side of the board you got both switches closed. And on this side you have one open.
Walk right down. The one line's on the front.
Is it?
The way I believe most,
Normally when we get that configuration,
you have both feeders in on both sides.
A and B and A and B.
Yes.
So
Yeah, that's not the way this
not the
one's
way-
set up.
okay.
Yeah. We feed in. This is wrong. This should go the other way. Actually, it depends on which way you have. You don't have A and B on both sides here.
Well, you know.
No.
Okay.
We talked about this.
A, B, B.
You have A and B.
Right.
So A comes in, comes through here, feeds this transformer, goes back up over here, and it stops right here. B comes in here, comes down, feeds this transformer, goes up, and it stops here. This switch is open. So you have A and B on both sides of this. It's a loop through. It's not an A, B on both sides.
That's what I missed.
So it's not a true A, B then?
No. Yeah, you do not have A and B on this side and A and B on that
I was
side.
confused.
Yes.
Okay.
Well, you use that as your switch. You can switch that one.
That's your open.
Right. That's your, yeah.
Yeah, basically it's
Got you.
We talked about this a long time ago.
never seen it done that way before. Never seen it done that way before.
Yeah.
that's something else we're gonna talk about too. We're gonna talk about how we're gonna label these just because of that.
Right.
So, in the back of these two sections before the mains are fire pump taps. Well, the fire pump taps are always live. There's no way to disconnect them out of the switchboards themselves. That's the MI cable that comes into each section. The only way to de-energize that cable would be to shut down the primary transformer and have the tiebreaker open. So,
Once you kill that, it's gonna start the engines anyway.
exactly, yes. Actually, I'm sorry, take that back. If you have to kill this
Right.
and open the main, and that will de-energize this section. But these do go to two disconnect switches over here. So you can isolate your normal feeder to transfer switches in the fire pump room. And then we'll look at the other breakers and the emergency switchboard when we get over there. Fire pump is over and out this door here, directly across the hall. There's two fire pump controllers in there. Again, 2 feeders from here, fire pump 1 and 2, and then 2 feeders from the emergency switchboard for fire pump 1 and 2. Back of the boards are all locked. There's really nothing in them except for the terminations, which we won't open up and looking right now. No real serviceable parts in there unless you're getting into PMs on the lugs and stuff like that. We got 480-volt distribution board over this side. This will feed all of our lighting panels, sub-basement, basement, second, and third floor. So any of those panels up on the floors in the small electric rooms, they all get fed out of here. We're going to transform to a 120-volt distribution panel here. Again, this feeds all of the 120, 208-volt panels, sub-basement, basement, second and third floor, up in the electric closets. So all those get fed out of, these are the normal distribution panels for all the electric rooms going up through the building up to 3. There's a lighting panel in, power panel down here for this floor. Every floor has a lighting panel and a power panel, or power panels on the floor, normal and critical. That's pretty much all that's in the room. This is our emergency distribution board. You know, the MI cables in the back, they go directly over to switchboard, the Russ Electric gear over there. This will feed all your emergency loads in the building. 5 transfer switches here, and the 3 over there, and then there's 2 on the ends of the fire pumps. Right now everything's racked out. We are not connected to the main building generator system at this time, which we're going to close LS, correct?
Right, once fire alarm gets on, we're gonna close the
We'll
LS
close the LS.
breaker, and we should lose that, we will start the generators.
Yep. The reason for that is with the fire alarm live on here, that's the circuitry that feeds all the nodes in this building. So we'll at least have backup power to them. Again, we have more of the transfer switches here. We have the X-ray, your life safety, critical, equipment 1 and equipment 2. The flywheels, you have 1 behind you and 1 over here. This feeds, this will do the X-ray, and this is our critical riser flywheel over this side. So we should see no blips on the going to generator power on those. The breakers in here and the switchgear is identical pretty much to the one over there. You get the ratchet inside for racking the breakers, controls in this area for the breakers and everything. It's different here. On the back side and the back wall is our distribution. Again, set up similar to the normal. Over here we start with the critical distribution. You get, actually I'm sorry. Critical distribution starts over here, MCI DSP. This comes right off the flywheel, so this is our distribution. Feeds over to this board here. Again, similar to the normal, this distribution board will feed all your critical lighting up through basement 2 and 3. There's no critical lighting panels down on the sub-basement. There's no critical power panels down on the sub-basement. That's the only difference with the normal. Panel next to it, the smaller panel, is our 122.8 volt critical distribution for basement, 2nd and 3rd floor. Also out of the main distribution panel here, this feeds up to the 4th floor. And again, you're gonna have a situation similar to this up on 4 that'll feed 6, 8, 9, and 10. 6, 7, 8, 9, and 10. We have an equipment board down here. This feeds off of EQ2, which is one of the transfer switches here. That'll feed all your equipment down here on equipment power. This also feeds up to the 4th floor. And that'll feed all the equipment up there. EQ1 riser, which is the other transfer switch, goes directly to the penthouse.
And the elevators are off of that one?
The elevators are off the penthouse.
And it's off of EQ riser.
EQ riser, correct.
It also feeds what, distribution?
This feeds the distribution panel up on 4 for all your equipment power.
If you gotta shut that down, you shut everything down.
You're going to shut sub-basement and 4th floor down here. You want to move up to the floors, take a look at typical electric room?
Sure.
You have two distribution boards up here, EDPCH and EQ4PH. EDPCH feeds everything related to the chillers, cooling towers, the pumps, basin heaters, anything related to the cooling system, if you would. EQ4PH will feed the rest of your mechanical equipment up here. Your air handlers, pumps up here, the elevator feeders are in here. We do have on the end a small normal distribution panel, DP4PH. Not a whole lot up here that's on normal power, but there are a few items.
All your chillers and all that stuff.
Anything related to the cooling tower, chillers, cooling tower, the pumps that are associated with it. Like I said, EQ4 does all our air handlers up here, all the other pumps and the other equipment, fans. This comes off that EQ1 transfer switch downstairs.
There's no breaker in between.
No, right off the transfer switch, right up to here. Same thing with that panel there. That comes right off of that ATS-CH over in the normal room, right up to here. And that could be put on to the generators, but it is a manual operation downstairs.
It's a main breaker. You got one for the panel, one for the
No, it's a chiller breaker. There's no mains in these are all main lug. You have two 800 amp breakers in there, one for each chiller. And there's two smaller chillers out the back here. We got a transformer here, transformer over there, so we got 122.8 volt EQ panels here and 122.8 volt normal panel on the other side.
What's a transformer?
Transformer? On did those. Yeah, there's no distribution out of here. This just all goes out and feeds equipment. We got two air handlers down here, one upstairs. The elevator machine room's down the other end. That comes out of here in MI. Those two MI feeders go to the elevators.
Out of here?
Out of here. That's these two breakers here.
How many elevators do you?
Two.
Just those two?
Just those two, yes. Cooling tower is over right up next to the elevator machine room, up on the roof. Basically right above the chillers. getting a little off of distribution, but all your air handlers up here have drives on them. A lot of the pumps up here are drives. There are a lot of starters also, but it's pretty even mix with a lot of it. Depending on the floor may determine how many panels are actually up here. 8th floor has the most panels, has 3 double tubs. This one has 2. Most of the other floors have 1 double tub and 1 single. And then the lighting panel.
Where's the feeds for these, up on the floor?
No, these will all feed out of 4. There'll be a distribution panel on 4.
Let's have a breaker on the floor just for these 2 tubs?
Yes.
Oh, it won't hit another floor?
Nope, nope, everything goes back down. Every panel, double tub panel up here has its
Same
own
with
feeder
these?
breaker. Yes. Yeah, this is RP210B, this is 210A. There's a breaker downstairs on 4 just for 210A,
So this will
210B.
kill half, that will kill on the floor
There,
per
yeah.
se. You got
Yeah.
like, you got outlets like from this panel and that panel in the same area?
A lot of areas, yes.
No?
Yeah, yes and no. For the most part, this does all your patient rooms. They will be mixed in there. This does pretty much all your patient room stuff here. This does most of the other smaller rooms
Are
and
they
stuff.
separated or,
I'm sorry?
they separate like basically if this is a patient room, you won't find one patient room in there?
There's no patient rooms in this one.
There isn't.
No.
Is that how
So,
it is all the way down?
For the most part, yeah. There are some rooms that'll have an A and a B panel in it. For the most part, all your patient rooms come out of A.
Yeah.
Yeah, so if you shut down the A riser, you're gonna take out most of your patient rooms, normal power. The emergency riser is set up the same way also. 10th floor does have life safety panels, so that's why they're here. Next set of life safety panels isn't down till 8. So 9 will have just the critical panels in the room alone. And again, these are the same as the normal panels. The breaker's down on the 4th floor just for each individual panel up there.
And safety's every 3 floors?
Yes.
What floors are that?
10, no, hold on. 10, 8, 4, 2,
Basement.
the basement. Again, it's a typical electric room with panels. This is the 480 to 440 volt transformer for the MRI. This is on this floor and the 2nd floor. These do come out of the X-ray riser. That is 480.
You have a separate one line for the X-ray riser?
Yes. So this and 2 are really the only 2 floors that are a little different because they have the MEG transformer and the MRI transformers. Yeah, here's the 4th floor distribution. Here's our DP X-ray panel. This only feeds 2nd floor and 7th floor MRIs. That's all there's in here. This comes straight up from transfer switch through the flywheel. We have EQ44. This is our equipment panels up here, double tub section. This feeds all the mechanical equipment on the floor, fed from the emergency system. We have 2 distribution panels here, 2 critical risers, A and B, 2 transformers, and then 2 120 volt distribution from here. So these go up and feed all the electric rooms, all our A and B panels up through the floors 6 through 10 for all your critical power in here. Our life safety distribution panel is up here. This comes directly from down in the sub-basement, up the transfer switch, right up to here, and it feeds up and down from here. There's also life safety 12208. We hit a transformer and feed that, and then that feeds up and down from here also. All life safety panels, I mentioned before, feed floor above, floor below. Other than fire alarm, and there's a few BAS points, life safety is corridor lighting and exit signs only. No room lighting or anything like that.
And the ATC is all off of critical?
For the most part, it's off at critical. There's 1 and 2 circuits. I think it might be 1 on this floor, 1 on the penthouse that are life safety. But yeah, for the most part, the whole system's critical. Normal router is DP44B, that comes up directly from switchboard downstairs. Again, we hit a transformer and our 122 volt distribution up through the floors. That's 6 through 10 in the penthouse for normal power. Normal lighting comes out of DP44. Again, 1 panel every floor. These are just lighting panels and power panels for this floor only. That's pretty much all. Yeah, I mean, again, it's almost typical all the way up except for the distribution panels, which feed.
Yeah, that's the thing we gotta get used to, the distribution, how it feeds between 4th floor goes up, and part of it goes down.
Yeah, you're a riser all the way up and tap over the other side, right? Second floor is similar to 7th floor. We got our disconnect fed from DP X-ray up on the 4th floor, 480 to 440 volt transformer. And it goes right over to the MRI. There is a disconnect in the MRI, breaker disconnect with shunt trip, but that's all part of the MRI equipment in there.
And the shunt trip just strips all that out there?
Just trips that one in the room, yeah. Yeah, it does not come back here. Other than that, yeah, again, typical electric room. 120 volt panels, double tubs, lighting.